Okay, so as we begin to finish up section 4.4 here, which is the laws of logarithms, was there anything from 4.3 or from 4.4 that you would like for me to go over? Okay, everything is good so far? All right, so I don't have a lot for today. You guys got through a little bit more yesterday than my other class did. So I only have a couple of things today to go through. We did, if I recall correctly, we combined logarithms and we expanded logarithms using the three laws yesterday. And so today we just have two pieces to go through. So the first piece, again from section 4.4, is something called the law of forgetting. Now, what the law of forgetting does is it's basically a measurement of how much you have forgotten over time. So, for example, if I gave you the same test today that you took the third week of class, I'm going to guess that some of you would not do as well. Just because you can't retain all of the material every time, right? I say this sometimes to counselors, because the fact of the matter is I teach math, right? So sometimes what happens is counselors will come to me and they'll say, this person took pre-calculus, but they haven't had math in 15 years. Where should they start? And I say, not with calculus. Well, but they took pre-calculus, so they should be ready for calculus. And I say, 15 years ago, they were ready for calculus. You have to imagine that if, for example, you played professional basketball, even if you played it for 12 years, if you then don't play professional basketball for 15 years, you're not going to make a professional team in year 16. At least you can't assume that because 15 years ago you played at a professional level, you can still match that level today. So what this law does, this law of forgetting, is it's a way to measure what your new mastery level would be. So if a task or skill is performed at a level, let's say P sub 0, then after a time, whoops, I'm having spelling issues today. After a time of T months, the performance level P will satisfy the logarithmic equation. where T is time in months, and C is dependent upon the task or skill. So C would be one thing if we were talking about playing basketball, and it would be a different number if we were talking about algebra. Know what you remember. Okay.
String rows.
Sorry?
I string rows.
Okay.
Oh. Yeah, it came back out now.
Okay, great. All right, so there are two things we want to do here. The first thing we want to do is we want to solve this for P. Now to do this, we will have to use the laws of logs. Which is fine because we just worked on those, so that part should be okay. Okay. Do you remember the three laws? Because if you don't, that's kind of a problem. Moving forward, right? Okay. So let's
The three laws, or
the three laws of logs.
like the log A plus log B, like it's like log A times B. And then the subtraction is division.
Yep.
And then the last one is like, I think it's like A to the C power equals log A C times A, or is it the other way around?
Yeah, log base A of A to the C would be C times log base A of that value, that base.
Okay.
So these are the three logs that we want to use in order to solve this for P. So the first thing we want to do is to take this right side and combine it to one log. So log of P is equal to. All right, so looking at this log of P sub 0, there's not a whole lot I can do there. But do you see how that C is in front of the log of T plus 1? That means I can take this C and using the third law of logs, I can take C times log base A of A and change it into log of T plus 1 to the C power. Now, these two logs are the same base, and they're being subtracted. So if two logs have the same base, and they're being subtracted, then I can combine them. And what can I do with these two results? Well, the subtraction tells me I can rewrite it as division. Now, as I look at what I have here, I have the log of p is equal to the log of p sub 0 over t plus 1 to the c. Are these also the same base?
Yeah.
What base are these guys?
Is it 10?
Right. These are common logs. When it's not written, these are both log base 10. So since they are the same log with, since they are logs with the same base, that means that p has to equal p sub 0 over t plus 1 to the c. I can also come to this, well, okay. So since they're the same log and the same base, that means those two values will have to be the same. If log of x is the same as log of y, then x has to equal y, right? But the other thing I can do is essentially raise both of those on a 10 and then the logs cancel. So you can do that either way and it will work. This is a property and this is a definition. All right, so there's part A. And then part B, just asks you to run it through something. If you're scoring a history test, two months ago, was a 87%. What score should you expect? On a similar test today? Keeping in mind that C is equal to a 0.15. So all I'm doing is plugging in the values. My initial score was an 87. So P is going to equal 0.87 over T is 2 months ago, so 2 plus 1 to the 0.15. And I get a 73.8. The good news is that is still passing. Questions on that guy?
No.
Good with the law of forgetting? I like the law of forgetting. I like
The law of what?
law of forgetting. Because it measures what I've forgotten, good or bad. All right. Okay, second thing for today is the change of base formula. Sometimes you're going to be asked to make calculations. With bases that will not work out well. And are not on your calculator. Or you may be asked to combine or expand logs that are not the same base. In these cases, the change of base formula is needed or useful, however you want to think of it. Okay, so suppose you have log base A of some value x, but you need log base B of that value x. So if you have to, say, calculate the log base 4 of 21, right? You're not going to be able to do log base 4 on your calculator. On your calculator, you only have two options for finding logs, for calculating. You have the common log, log base 10, and you have the natural log, ln. So, how do I want to say? Let's say you're needing log base B of x, and that's going to be some value y. Now, in exponential form, this is b to the y is equal to x. So if I were to switch that up, that's going to be my exponential form. So if I need my calculator, there are only two that are useful for my calculator. One, you can use log base 10, or you can use ln. And we're limited to those two because, again, they are the only two on this calculator. So I can take the log of both sides. The log of by is equal to the log of x, or I could take the ln of by. Using my laws of exponents, I can take that y out front. so that y times log b is equal to log of x. And dividing both sides by log b, I get y is equal to log of x over log of b. For those of you that prefer the ln, I'd have y times ln b is ln x, or y is equal to ln x over ln b. Both of these bring us to the change of base formula. Which says, if you have log b of x, that is going to be the same as log a of x over log a of b. This allows us to convert conversion to any base. But we use log base 10 and ln for calculator. Questions?
I don't have any.
Okay. All right, let's try a couple of change of base formulas just to see how you will use it in this assignment, which is only for calculations. All right, so we want to use the change of base formula to evaluate these problems. Log base 5 of 21. So, once again, on the calculator, we can only do a log base 10 or a natural log. So I don't actually know what log base 5 of 21 is. I don't know what 21 is as a power of 5. It's 5 to what power? I don't know. I mean, I can tell you it's between 1 and 2, because 5 to the first is 5 and 5 squared is 25. So I know to get a 21, my power needs to be someplace between 1 and 2. But I don't know what that number is. So what we do is we change the base. And you can use an ln of 21 divided by an ln of 5, natural log. Right? So then all I do is on my calculator, I do an ln 21 and I divide that by an ln of 5 to get a 1.89 or 892 if they want 3 places. Notice I knew that this answer was going to be between 1 and 2. And since 5 squared is 25, I was pretty sure it was going to be closer to 2. It is of note that if I had done log of 21 over log of 5, I should get the exact same answer. Oops. So log of 21 divided by log of 5, and I still get the 1.892. I will make mention that for this calculator specifically, watch your parentheses. If I don't put my parentheses to close the log before I hit my division sign, I will get an incorrect answer. At least on this calculator. So be very careful about your numerator denominator steps. If we have to evaluate, the log base 12 of 125. I don't have a base 12 on the calculator. I have to either do ln or log base 10, and it won't matter which. So this would be the ln 125 over the ln of 12. And for those of you who may be interested, I know 12 to the first power is 12, and 12 squared is 144. So this log base 12 of 125, again, has to be someplace between 1 and 2. And I'm going to guess a little closer to 2. And get a 1.943. And again, had we used a log, we should get the same answer. It's just whichever one you like better for these. Questions for me?
No.
Okay. This is all I have for today. Since yesterday went so quickly, this is all I've got for today. I just want to remind you then that tomorrow is not new material. Tomorrow is just a question and answer for any of the homework that you have for this week. As a reminder, tonight you have 4.3 due, and on Friday you have 4.4 to complete.
All right. Sounds good.